Hey, welcome back again. Last week we looked at the Mandelbrot set, and towards the end we discussed about zooming in into the Mandelbrot set and how you would zoom into the Mandelbrot set, right? I mean, I had a couple of ideas, and I had some free time today in the morning, and I wrote this piece of code in Java this time. I mean, when we built it in JavaScript. But then I've rewritten this in Java so that the processing is a lot more faster, and then so that I'm able to zoom into the Mandelbrot set. All right. So I'll just show you the code. So I think it's Control 5 to show the code. So this is written in Java. Once this is done, I'll upload this onto GitHub, and I'll link the GitHub. I'll link the GitHub source code onto the video description. All right. So that being said, the only thing that I have changed from the original Mandelbrot set code, everything else remains the same. The only thing that I've changed is that I now have minimum x values and minimum y values. All right, so we only had a couple of variables last time, which is the minimum and the maximum. We ranged all of the values in the Mandelbrot set from -2 to 2. So I now have x and y values for them, and you will see in a short while why. All right. The other thing I've changed is the max iteration. So we stopped iterating at 1,000 iterations. Over here, because I wanted to zoom in and because I wanted to see how long, because I wanted to get more and more details, I'm iterating it to 10,000. All right. So keep in mind that when this Mandelbrot thing is happening, or when we are zooming in, each pixel is evaluated 10,000 times, or has the potential to be evaluated 10,000 times. Each pixel it happens. All right. So let's just go to the Mandelbrot window, and I'll show you what I mean. All right. So this is the Mandelbrot window. Let's try and zoom in into one of these spots. All right. So the zooming in is not that perfect, but it'll at least get you closer to it. Remember how I was telling you that the Mandelbrot set contains many more Mandelbrot sets within itself? This is what I was talking about. So that's the Mandelbrot set. All right. Let's go into one of these small arms. And this is it. There you go. You see these weird fractals. And there again, once again, you will see a Mandelbrot set. This never ceases to amaze me. It never ceases to amaze me that you can go into such detail and still find a Mandelbrot set over here. All right. And even if you have not seen the main video, and if you're just seeing this video, and if you're wondering how I coded for this, I didn't code for this. It's that same formula, z square plus c, which is creating these wonderful fractals, these wonderful fractal patterns. I have no idea, or I have very long ago lost the idea of how that simple formula can create such beautiful patterns, or these patterns are hidden within the Mandelbrot set. All right, so let's just take a moment to sort of zoom into the Mandelbrot set. All right, let's take one of these small arms and see what's there. It's going to pixelate pretty soon, but I just want to see at what point it starts pixelating. Again with the patterns. I think it's ended now. I think those 10,000 iterations are no longer enough, and I think we've lost some details. I think after this point, it's only going to start to pixelate. All right, yeah, so there you go. So that's the pixelation, because the number of iterations, 10,000 iterations is not enough. Remember what I told you last week, the more iterations you go, the more you will have to, the more in depth you go into the Mandelbrot set, the more iterations you will have to perform. And this is a demonstration that the number of iterations is just not enough. And I think we would have zoomed in about 1 billion times. I mean, we are now a billion depths into the Mandelbrot set. Yeah, so that's all I wanted to show you. Thanks for joining. I'll once again, just to reiterate, I'll put this code onto GitHub, and I'll link the GitHub source code onto the video description. Thank you for joining.